guys, I've been getting some questions about the vector lesson. So I think it's because trying to use the cute situation that the Georgia Department of Education gave to us to use, I think it's just throwing you off. So here's just going to be a quick, here's what you need to know. So for vectors, a vector is a directed line segment. So you already know that a line segment has two endpoints, right? So that's a line segment. A directed line segment is where you actually have an arrow showing the direction that you are traveling. So this is the starting point and this is the ending point, or the initial point and the terminal point of our vector. Okay, so a vector is just a directed line segment. So vectors have a magnitude and a direction. So the magnitude of the vector is the length of the vector, which is the same thing as saying it's the distance between the initial point and the terminal point. So since this is perfectly horizontal, you can just count how long this is. So 1, 2, 3, 4, 5, 6, 7. So the magnitude of the vector that I drew right here is 7 units. So that's how long it is. The direction is the angle at which that is pointing, that vector is pointing at. And so this just throws it back to unit 1 where we were drawing angles in standard position. So if you just kind of imagine, you know, your x-axis and your y-axis right here, if you imagine that initial point being at the origin, then you know if your terminal side of your angle is right here on the positive x-axis, you know that that's 0 degrees. So the direction is just the angle measured from standard position. All right, so if we look at this vector here, okay, so here I have a vector. So if I look at this vector, my initial point is here, my terminal point is here. So if you imagine this initial point on the origin, right? Now it looks like what we did back in unit 1. The magnitude is going to be the length of this arrow or vector that I've drawn here, and the direction is going to be this angle right here measured from standard position, which we know 0 degrees, or the initial side of our angle, is always on this positive x-axis. So in order to help us find the length or the magnitude of this, you can look right here. Look at that. You can make a right triangle out of this vector. Do you see that? Here's the vector that I'm trying to find the length of, but if I know this x distance here and this y distance here, which I can count, 1, 2, 3, 4, and this is 1, 2, 3. So this makes a right triangle. If you have a right triangle and you know two sides of that right triangle, well, how do you find that third side? Pythagorean theorem. So you would do 4 squared plus 3 squared, right? A squared plus b squared equals c squared, right? So that would equal this x squared, or that magnitude that we're looking for. So 4 squared is 16, 3 squared is 9, 16 plus 9 is 25, and then since 25 is x squared, in order to just get x, square root both sides, and we get 5. So the magnitude of this vector that I drew here, or the length of it, is 5 units. Right? 3, 4, 5 triangle. To find the angle Well, again, this is a right triangle, isn't it? So the direction is the angle. And to find this angle in this right triangle, 3 is the opposite side, 4 is the adjacent. Think back to analytic geometry, right triangle trig, opposite over adjacent, that's tangent. So to find the direction, we can just use trig functions. The tangent of our angle is the opposite over the adjacent, 3 over 4. And then we know that if we're ever trying to find an angle measure, to move that trig function over, we have to do the inverse. So, whoops, sorry, I was off this page there. So you have to do the inverse. So tangent inverse of 3/4, you would just type that in. I'm going to make sure I'm in degree mode because I want my answer in degrees. So tangent inverse of 3/4 gives us 36.87 degrees if we round. So that's the direction. We found the magnitude and the direction using this x and this y. The x and this y, these are called the components. The components of the vector. So the components, they have that horizontal x component and they have that vertical y component. So this vector can either be described as having a magnitude of 5 and a direction of 36.87 degrees. Or we could also describe this vector just in terms of their components. And this is the component form. This is where you use the little pointy parentheses there, the pointy brackets, I guess. And you put the x and then the y. So the x was 4, the y was 3. So the component form of this vector that we drew here is 4, 3 like this. So if you're given these components, then you can find magnitude and direction by using the Pythagorean theorem in your right triangle trig. So that's how to convert from component form into magnitude direction form. Hopefully that helped. Please email me if you have any other questions.